Welcome. Last time we looked at the definition of Riemann sums, saw how to write down Riemann sums in specific cases. In particular, we have the Riemann sums using left-hand endpoints, right-hand endpoints, or midpoints. Let's do an example where we calculate these. We will approximate the area bounded by two vertical lines, x equals 0 and x equals 1, the x-axis, and the graph of a function, y equals square root of 1 plus x squared. We are going to use 5 subintervals, so n is 5. The interval runs from 0 to 1, so a is 0 and b is 1. The function is square root of 1 plus x squared. H, the width of each subinterval, will be b minus a over n. In this case, that's 1 minus 0 over 5, or 0.2. So our subintervals will run from 0 to 0.2, 0.2 to 0.4, so on. So let's write down the Riemann sums. For the left-hand endpoints, the endpoints will be 0 for the first subinterval. Plug that into the function. That gives me square root of 1 plus 0 squared. For the second subinterval, the left-hand endpoint is 0.2. We can figure this out by just starting with the leftmost endpoint and adding 0.2 at each step. Plug that into the function and write down what the value is. I'm going to do this for the remaining 3 intervals. Next one will be at 0.4, then at 0.6, then at 0.8. I have to multiply each of this by 0.2 and add. I might as well add and then multiply by 0.2 at the end. If you do all the arithmetic involved and round off the answer to 4 decimal places, you should get 1.1087. For the right-hand endpoints, I need to start at 0.2. The first subinterval goes from 0 to 0.2. The right-hand endpoint is 0.2. So I take the value there. The next one will have a right-hand endpoint 0.4, then 0.6, then 0.8, finally 1. Note that if you use left-hand endpoints, you start at the leftmost point of the whole interval, that is at A. If you use right-hand endpoints, you are going to stop at B, in this case 1. This comes out to be 1.1916, correct to 4 decimal places. If I use the midpoints, they are still spaced by H. The first subinterval's midpoint will be the midpoint for 0 and 0.2. 0.0 plus 0.2 divided by 2 is the midpoint, and that's 0.1. Take the function at 0.1, square root of 1 plus 0.1 squared. Then for the next interval, the midpoint will be 0.1 plus h, that's 0.3. For the next one at 0.5, then at 0.7, then at 0.9. This comes out to be 1.1466. If you look at this, you notice that they are not that close together. They are off by roughly 0.1. In this case, I have an increasing function. For an increasing function, as you can see from the picture, left-hand endpoints give an underestimate, right-hand endpoints overestimate, midpoint is somewhere in between. And if you look at the picture, it looks like it leaves some on one side, it adds some on the other side. It's a question of how far they balance each other. For functions that don't vary very much, they balance each other to some extent. So we should normally expect the midpoint to be better than other points. We'll talk about this in a later example.